Okay, I'd like to introduce everybody to the Frontiers of Geophysics lecture. As most of you know, this is the union-wide lecture of the fall meeting. And before we start, actually, I'd like to take the opportunity of having a sizable number of people in one place to do something that we never get to do at the full AGU meeting, which is to acknowledge the group of people that actually make the meeting happen. And that is not just the scientific program committee, but more importantly, in fact, the AGU staff who make sure that all the things that if they were left to us to do would not be done or would be done terribly, they make sure that those things happen. And so I'd like to in particular acknowledge Brenda Weaver and Joanna Ward and Melissa Markovitz. So it's my great pleasure this evening to introduce Dr. Marcia McNutt, who, as you know, is the director of the United States Geological Survey. And many of you know Marcia or have known about her career, but for the people who haven't followed her career, I wanted just to touch on some of the highlights. Marcia obtained her bachelor's degree from Colorado College in physics. And she then went on to Scripps Institution of Oceanography, where she obtained her PhD, and then, in fact, spent some time at the USGS in Menlo Park, where she worked in part on earthquake prediction. She went from there to MIT as a professor, where she held the Griswold Professor of Geophysics chair, and just over a decade ago, in 1997, she went from MIT to MBARI, so the Monterey Bay Aquarium Research Institute, where for the past 12 years she has been the director and the chief executive officer. And her work there has been nothing short of amazing in terms of coordinating and bringing together both scientists and engineers and technical staff, and really leading the way in some cutting-edge technology and scientific efforts. She now, as you know, is the director of the USGS. She's the first woman director of the United States Geological Survey in its history, so since its inception in 1879. And she also serves as the science advisor to the Secretary of the Interior. And this is a position that hasn't always existed. She's certainly the first geoscientist to have such a position. So as a group of scientists and as an organization, we're well served and honored to have Marcia representing that role for us and for other geoscientists. And Marcia is known for her work, her scientific work, pertaining to studies of both the oceanic lithosphere and of the continental lithosphere, in particular looking at the superswell in the South Pacific, work in Tibet, and work in Western North America. And for many of us in science, our careers are made up of many, many small moments. If you're lucky enough to be like Marcia, there are a few very big moments along the way too. But one of my small moments was very early on in my career. It was in fact my first exposure to Marcia's work, and it was in about the second year of my PhD when I was just getting started on research, and I'd spent many days, many weeks in the library trying to figure out how on earth I was ever going to pull together a research project that could possibly constitute a PhD. And one of the papers that I read at the time was Marcia's paper with Bill Menard on constraints on the yield strength of oceanic lithosphere from observations of Fletcher, which was a paper I then ended up using in some of my own studies. But more importantly, I went to my advisor at the time for that particular study, David Samwell, and I said, so what does this lady do now? And he said, oh, she's a professor at MIT. And I was sort of in the depths of not really sure what this geophysics thing was or how it was going to work out in the end. I thought, well, maybe this can work out. So thank you for that. And so it's my great pleasure to introduce Marcia. She's going to speak Today, on USGS science, the title of her talk is The Tip of the Spear, Cutting Edge USGS Science.
Well, thank you very much, Catherine, for that great introduction. It's wonderful to be back here on the West Coast after spending the last month in Ruston. Actually, spending the last month on airplanes is really the truth. But I'm really pleased that Catherine gave me this chance to give this talk because the first thing I had to learn when I became the director of Imagery 12 years ago, after having been a professor at MIT for so many years, was how to enjoy science vicariously. Because no longer was I doing my own science and coming to a meeting like this and presenting the results of my own personal research, but rather I would go to various venues and have to present secondhand the work that other scientists were doing and engineers. Now, the wonderful thing about being the director of Imagery was that there were so many great researchers there doing fabulous science that I learned to love giving talks about the work that other researchers were doing, because instead of just talking about my own research, I could cherry pick the results of all the great work that all the other Imagery scientists were doing and wow audiences with the weird and wonderful. The science that you had to be a great science fiction writer to come up with, you know, bone-devouring whale worms, or the photosynthesizing bacteria that were the biobatteries, or, you know, all the great stuff that, you know, people in the audience here, Charlie Paul and Peter Brewer and everyone else were doing. You know, it was just cool, cool stuff. So I thought, when Catherine asked me to give this talk, and I had only been at the USGS for a month, what a great opportunity to put out a call to all the USGS scientists and say, what's the cool science that you guys are doing? Because, you know, knowing that, I'm not advancing here, I guess. Will this work? Yeah. Okay. I know that a lot of you are familiar with the USGS, and you know that it's a mission-oriented agency. And so most of you know that the USGS is mandated to do Earth resources assessments, so they maintain the water gauge network. So many of you might be hydrologists, and you know all the work they do to maintain accurate assessments of snowpack and water flow and groundwater assessments. They do a lot of work in fossil fuels, how much oil's in the ground, how much gas, how much coal do we have, and they do the only up-to-date assessments of strategic minerals as well. New, well, relatively new mission for the USGS is assessing climate change. For all of the GS history, basically, they've been doing hazards assessment. And of course, the USGS has a large group of biologists that do ecological baseline investigations and endangered species assessments, et cetera. They maintain long-term, extensive, consistent databases, which is a USGS hallmark, and the USGS is well known for coming up with standardized ways of going about data collection. So all of this sounds like it could be very routine, very much yeoman's work, which is, of course, essential and something that you need a government agency to do. But the question is there going to be cool science as well? And so that's what I went out with the call to the troops to come up with your cool science. Now, some of you, but hopefully not many, may be thinking, well, you know, there's this continuum between basic research and applied research. But I think a more modern way to look at it is more a two-dimensional plot, at least 2 dimensions, maybe more. And this is a diagram in which you might look at where research falls in a two-dimensional scheme, where you could imagine a project falling somewhere in a plot where socially relevant research falls from left to right, and how applied versus basic the research falls, with applied research being in the lower left-hand corner and basic research going up the plot in the vertical direction. And something called Pasteurs Quadrant is in the upper right-hand corner. So it's research that's very basic but very socially relevant at the same time. So that's, for example, the discovery of penicillin. It was very basic research but very socially relevant at the same time. And so what we're looking for here is research that has the USGS research, we can look at it over on the right-hand side as being socially relevant, but everything from very applied to very basic. And what I wanted to get for this talk is the research that's up in Pasteurs Quadrant. So now the disclaimers for this talk. The disclaimers are there were some good ideas that were submitted that unfortunately had to be dismissed out of hand because they just didn't make a good talk, because they weren't very visual. You know, things that had to do with modeling, data standardization and integration, I just couldn't stand up here and wave my arms and make you understand it or appreciate it. So those, you know, with apologies to those who submitted those great ideas, I'm sorry I'm not a good enough speaker to get those across to this audience. I also omitted great stuff that's being done with, for example, the Landsat program. But I'll tell you, I just got back from Copenhagen, and my message over there was lots of great stuff about the Landsat program. So the message got to the people over in Copenhagen about the great stuff being done with Landsat in terms of biological carbon sequestration and deforestation and other things that are being done with the Landsat program. So the message got to the right people there. And finally, this just isn't a complete list because of time constraints and other reasons. So if you submitted a great idea and it's not in here, well, I have filed it away and it will make it into another talk at some other time. So thank you all for your contributions. Okay, so the first topic I'm going to cover is LiDAR. There were lots and lots of contributions under the general topic of LiDAR, really interesting applications of LiDAR for a number of different studies. So, go to LiDAR. So, what's LiDAR? LiDAR stands for Light Detection and Ranging. And basically the concept behind LiDAR is that light is emitted in pulses, and the pulse of light can be tuned to various frequencies, and then the scattered light off the Earth's surface is measured, and the time of the pulse is detected such that one can then image the ground surface for a variety of purposes, which I'm going to show you. And these are just some of the applications that I'm going to go through in more detail. But basically, they're for everything from urban studies to the hydrologic cycle, land cover, biomass, hazards, etc. So let me go into some of those in more detail. Here's an application of LiDAR for studies of infrastructure, and this is one in which LiDAR is actually combined with optical imagery to yield precise structural depictions of buildings. So the LiDAR actually gives you the 3D, where the visual gives you the beautiful imagery of what the buildings actually look like, and the LiDAR gives you the 3D image. So that one was a pretty cool rendition. You almost feel like you actually were there and looking at someone actually took a 3D picture of that from that. Here's an example of LiDAR used in the case of a natural disaster. This is a reservoir in Hawaii where a dam broke in 2006. People actually died from the flood of this dam breach, and LiDAR was used in sort of the forensics afterwards to help image the dam failure and determine where the flow started and where it went, and figure out what the cause of the failure was. Here's a third example, and of course in all of these the LiDAR is tuned to various frequencies for these applications. This one is from the Sierras, and Gerald Bodden from Sacramento Water District, USGS Water Division in Sacramento, gave this one. And here LiDAR is being used to precisely monitor the snowpack in the Sierras. And in this case, the LiDAR can see through the snow to measure the amount of snowpack. And when you compare this, this remote sensing technique to measure the snowpack compared to actually sending people in and actually having to measure the snowpack through boring through the snow or some other means, this is certainly more precise and less time-consuming and allows annual comparisons from year to year of the amount of snowpack that's crucial for water management. This is an interesting application of LiDAR that is deployed from an airplane, where the energy returned from the LiDAR is used to produce position and intensity information that is used to distinguish, I don't think I'd be so bold, but obviously the interpreter here has distinguished trees from different kinds of roofs, grass, and water in this image by just flying over the land surface. So obviously very interesting interpretation of that scene. Here's another one from Airborne LiDAR. The one on the left is the visual image of a tree-covered scene, and the one on the right is the LiDAR. This is from Greg Snyder in the Geography Division in Reston. And in this case, the LiDAR energy has traveled through small openings in the tree canopy to characterize the underlying terrain. So this is a way to map the land surface through the forest canopy in order to get terrain despite the tree cover. So, you can't see the forest for the trees. Well, you can see the land despite the trees. Here's another one, another application from Greg Snyder, using a slightly different application of LiDAR in forests. And this is used for when you need to assess how much carbon is stored in forests. In this case, we're not trying to see through the trees, but actually trying to measure the amount of biomass stored in the tree. And what he shows on the left here is the modeled tree volume based on the backscatter from the LiDAR, and then they went out to ground truth what the LiDAR estimated the volume of the tree to be with the actual tree, and you can see that the comparison was actually quite favorable. So that's a pretty amazing comparison between the actual tree and the modeled tree. And of course, remote sensing of biomass of forests is going to be increasingly important with countries wanting to use carbon stored in forests to satisfy requirements for carbon credits. Okay, so enough about LiDAR. Let's go on to some other topics. This one about earthquakes was submitted by Bill Leith, and this one is about an earthquake early warning system, which is incredibly cool. And in the next 30 years, there is a 99% chance of a magnitude 6.7 or larger earthquake in California. So that sounds like that's a pretty good chance. So there's a program that the USGS is working on called the Advanced National Seismic System, using California's integrated seismic network that will build a prototype statewide earthquake alerting system. And the idea of this is that with an automated system that wouldn't have a human in the loop, that would trigger when the earthquake happens, because the most destructive waves are the surface waves that come in later in the earthquake train, that an early warning system might give several minutes warning that, depending on how far you are from the epicenter, seconds to minutes warning that would give enough time to, say, automatically shut off gas mains or other kinds of automated responses that could reduce the destruction in an earthquake and at least reduce fires. It could stop, for example, trains in subways and things like that that could be important first responses to a major earthquake. So that project seemed pretty cool. This is a picture of airborne geophysics being accomplished over volcanoes. This was submitted by John Eichelberger at the USGS Cascade Volcano Observatory, and this is a helicopter flying magnetometer and EM sensors. And this project integrates geophysical data with mapping data and other hazard data such as pyroclastic mud flows and landslide data to improve hazard assessments. And they've done this over Mount Adams, Mount Baker, and Rainier. And they use this to get the three-dimensional distribution of hydrothermally altered rocks, perched aquifers, and ice so that they can actually see through the snow cover on the volcanoes. And so what that looks like is, here's a picture of one of the volcanoes, and this just shows their views that they can see of where the hazards would be from where they believe the hydrothermally altered rocks are and where hazards would be for pyroclastic flows. So they can use this to better understand water supplies and debris flows, avalanches, flooding, etc. Mike Hutt submitted this photograph of USGS work in unmanned aircraft. Unmanned aircraft are becoming an important tool in field work, particularly in remote areas such as polar regions, in volcanic islands, desert areas. They can provide detailed and timely data about environmental conditions that we can't get from any other way. For example, often our satellites are shielded by cloud cover, whereas these aircraft can fly under the clouds. They're much less expensive than using manned aircraft to get data, especially using sensors that are miniaturized enough to go on an unmanned aircraft. These often can fly too. You can put them up at times when you might not want to risk manned aircraft. So this is an increasing tool in the arsenal of USGS technology. One project that I think is very timely for talking about here in California is understanding atmospheric rivers. This has gotten a lot of press here in California because although we used to think of the atmosphere as being more or less homogeneous, we now know that the moisture in the air is very non-homogeneous, and that there are enormous channels, sometimes hundreds of miles wide, that are more similar to almost rivers in terms of the amount of atmospheric moisture that they carry, and that they play a critical role in global water cycles and in the amount of moisture that falls to the, particularly here in the western states. The USGS has been collaborating with NOAA in trying to understand what forms these atmospheric rivers and where they release their moisture. You've all probably heard of these arc storms, and trying to understand, better predict when they form. The International Atomic Energy Agency was so interested in these atmospheric rivers and the arc storms that they provided USGS funding for a cooperative modification of the collector shown here for use in arid environments, especially in Africa, where collection of precipitation has been very challenging. And this was submitted by Ty Copeland from the Water Resources Division in Reston. One project that I believe might be ultimately of great humanitarian benefit is the work that people in our Denver office, Trudy Ridley and Raymond Coakley, have done in Afghanistan. In the fall of 2007, our scientists conducted a nationwide airborne hyperspectral survey of Afghanistan. This was done in conjunction with NASA. Also, the U.S. Secretary of Defense, the Afghan Ministry of Mines, and the U.S. Agency for International Development. This was the first hyperspectral survey of an entire country that was ever done, and the largest hyperspectral data collection ever by any agency or organization. And hyperspectral imaging measures reflectance of spectra in the visible and infrared radiation band, and the patterns can be used to uniquely define certain minerals. And Afghanistan is a nation that is absolutely wealthy beyond your wildest dreams in minerals. And when we talk to people from Afghanistan, they will tell you that for the most part, people in Afghanistan are not really happy about the Taliban, but the Taliban offers the young people of the country something to do. They offer them a job. But they have not, the young people have nothing else to do. They don't have jobs. And if data sets like this can provide options for mining and other sources of income by showing where there's mineral wealth in Afghanistan, I think the USGS will have done a good service to the people of Afghanistan. This shows the kind of terrain that this data set was collected in. Clearly, there would have been no other feasible way to get this kind of data set over such a rugged country. The cost savings of the Airborne survey is tremendous. And there's a possibility we could use this technology right here in the United States. So it's really got pretty staggering potential. Okay, this is a map that the USGS put together of methyl-mercury concentrations. Mercury, as you all know, is a poison. It's hazardous to human health. And mercury becomes concentrated in the food chain. Because it's not eliminated from the body, as it moves up the food chain, it gets more and more concentrated into higher levels in the top predators. And the way it gets into the food web is through mercury methylation. So what this map that the USGS put together, it shows the levels of mercury methylation in the country. So by looking at this map, you can tell where the red hot colors are, where there's more mercury methylation in the aquatic food webs. And so, you know, if I were you, I don't know if I want to eat a fish from Florida. But it's probably okay to eat one from, say, Long Island Sound, because that's sort of the extremes on this map in terms of the degree of mercury methylation. Okay, biochar. So what's biochar? This is a project that was submitted by Colleen Rostad from Water Resources in Denver. And biochar is basically charcoal that's created from biomass by charring biomass. You can see a bunch of biomass here that was just turned into a charcoal. And the charcoal that results from this is a form of biosequestration of carbon that was sequestered in all of that biological material. And once it's put into that charcoal, it's a stable carbon-rich form that can then be tilled back into the soil. And once you do that, it improves the water quality of any water that is filtered through that soil. It increases the soil fertility, and it raises the agricultural productivity. So the USGS has extensive experience with the charring of this natural organic matter, and is doing research on this in conjunction with the Department of Agriculture and the Department of Energy in their National Renewable Energy Laboratory. And the U.S. Forest Service has expressed great interest in the USGS studies in this field. So that's pretty exciting. Now, this one kind of doesn't photograph real well. But this is a multi-collector inductively coupled plasma mass spectrometer. but even though it doesn't photograph very well, it does some pretty amazing things. This came from Michael Pribble in the Denver office, and we'll have to trust him about the amazing things it does. He's collaborating with EPA and several universities in tracing, because of the very precise measurements that this mass spec does, in tracing copper, iron, and zinc in acid mine drainage areas, mercury and lead isotopes for geochemical tracing in contaminated sites, lake sediments, and soils. And for the first time, he can determine high-precision sulfur isotope ratios in fossils, even though they've got low sulfur concentrations. And he's going to use it to learn more about paleoclimatic records and evolution of ocean chemistry throughout the Earth's history. Okay, so let's go on to water on the moon. This came from Roger Clark in the Denver office. These are spectral images. The ones on the left came from NASA's Visual and Infrared Mapping Spectrometer, or the VIMS instrument on the Cassini orbiter, which flew by the moon on August 19th, 1999. And after 10 years of calibration refinements, an in-depth USGS study of spectral images obtained from space satellites and analyzed through infrared imaging spectroscopy revealed that water exists at all latitudes on the moon, including the equator. So that was pretty cool. Okay, this one I really like. This is a plasma torch that is blasting Earth materials that have the same basic mineral composition as moon materials to make fake moon dirt for NASA so that they can make fake moon regolith so that they can practice for their moon facility. NASA wants to make a moon station at the south pole of the moon, and they've deemed it a mission critical component to have enough moon dirt to, for testing. And so the USGS figured out how to make fake moon dirt. Here it is. Thank you. Okay. Here's detecting Martian caves. Okay, so this is good news for those of you who are going to be on the first mission to Mars. USGS scientists, this was came from Glenn Cushing, who's, and the fake moon dirt, that came from Steve Wilson at Denver. This is Glenn Cushing from Flagstaff. And Glenn used high-resolution images from Mars orbiting satellites to look at this strange-looking feature that was on an image from Mars that had this very intriguing-looking depression. And he figured out that this formed from a collapsed lava channel over an ancient volcanic eruption. And so it was a collapsed lava tube. And so it created a cave. And NASA decided that a system of caves is of particular good luck for the astronauts because it could provide shelter for the astronauts who first land on Mars. And these caves might also be the first place to look if you want to look for microbial life on Mars. Go to the caves. So that's probably going to be X marks the spot for people going to Mars. Thanks to Glenn. Okay. And here a little closer to Earth, arsenic may hold the key to what that first life might look like, given that water and oxygen don't seem to be all that plentiful in some of these extreme bodies in the solar system. So arsenic-eating bacteria might be more akin to what life might be like on some of these other bodies in the solar system. So USGS scientists, with the support of NASA, have discovered that microbes existed on Earth much earlier than expected. And organisms were discovered on Mono Lake in California that live in hot springs which were alkaline, and they were arsenites and arsenates. That the study showed that they use arsenic for photosynthesis instead of oxygen. So very clever little guys. All right. On to gas hydrates. This one made quite a bit of news when it first came out. This was, of course, you know, we've known about gas hydrates on the continental margins for a long time, but there was general concern that the gas hydrates might be too dispersed for economic recovery. And this shows a USGS project that was joint with industry that drilled into a gas hydrate-bearing sand in the Gulf of Mexico that discovered a deposit that actually was of resource quantity and actually would be worth exploiting. And this joint activity featured a number of technical advances, including advanced logging while drilling tools that provided three-dimensional images of the hydrate-bearing sediments, and it imaged the amount of resources down there. And that came from John Kolak from Reston. And this one came from Carolyn Ruppel in the Geology Division at Woods Hole. Gas hydrates, of course, are also implicated in climate change, and USGS has been studying methane hydrates for their impact on global warming and stability of the Arctic methane hydrate deposits. You can see the North Slope up there. And so with support from the Department of Energy, USGS is using geophysical and geochemical approaches to study sites on the Alaskan North Slope and the Beaufort Shelf to determine how quickly they're degassing, if they are, and by what mechanisms the methane will reach the atmosphere, and how they will affect, how climate change will affect that baseline. Okay, so in conclusion, this was just a quick trip through some of the science that the USGS is doing. I think you can see in every one of these projects, they all line up with those current missions that the USGS is required to do, but all of them also are, you know, good science from the standpoint that I think the people involved in them are interested in what they're doing, they're excited about their science, and they're pushing the frontiers of research forward. I think they all fall within Pasteurs Quadrant, and I'm really proud to be leading this group of scientists. So thank you all for your attention. I'm happy to take questions, but of course I probably won't be able to answer them because these are other people's science. Yes, question. The question was about the Transparency Act making data available to the public and to, yeah, the scientific community. USGS data is for the most part available, so I'm not sure that really applies as much to the USGS as it might to other agencies. The one thing about the USGS is that all of our work goes through peer review, so that we don't release anything until it has been through peer review. And so the thing is, if you as a peer reviewer don't find there's enough data to support that conclusion, you would have to say, there's not enough information here, you need more, I need to see more data, whatever. And so it gets kicked back, and so we can't even release anything or whatever because it hasn't been through peer review. There are some other agencies, for example, that might make a decision that because they're not required to do things through peer review might have more problem with that. With the USGS, because everything has to go through peer review before we do anything, I don't think that's going to change our modus operandi as much. Yeah.
So I have a question about what you see in your copious free time in the past month and a half, whether you've had a chance to think about how you see the role of the USGS internationally. So you gave this wonderful example of the data from Afghanistan, and obviously the primary mandate of the USGS is a domestic one. I wondered if you wanted to comment on what you see as the role internationally, either in science or in hazards.
That's such an excellent question, Catherine, because I just see so much opportunity for cooperation and in some cases leadership in so many areas. I think it was my first week at the USGS. I spent time at the GEOS conference and at a conference with Brazil in which we were discussing areas in which USGS was involved with Landsat and with other programs. The problem we have is not with opportunities, it's just with funding. It's really with funding, because I see every single person at the GS is stretched so thin. The one thing that I have noticed since I came to the GS is that everyone is working 24/7 and just going as fast as they can, trying to get everything done. And the one thing we've done is we're almost a victim of our own successes because of the fact that people the Landsat data now has gone, is free, available to anyone over the internet, and so now everyone's downloading all of these data, and people now want help with, using the data, and it's just, and the hazards program now is so successful, and everything else, all these programs are so successful, people want help copying these programs, and there's just so much opportunity and only so many people. Well, a couple of fun things that I saw there. First of all, there were, again, lots of opportunities for Landsat data to be useful. One interesting talk or announcement that came from Google, where they are using the power of their cloud computing with USGS Landsat data and algorithms that take our 37-year record of land scene changes to allow people in near real time measure changes in carbon storage in the forests for any place on the planet. And that's a pretty powerful thing to be able to do. And they're basically offering this up now in pretty much real time. So, and it's all been enabled since we've been offered up the Landsat data free, and they're offering up their cloud computing. So that was great, and that's all going to be they're putting this out as part of the UN RED framework, where RED is a reduction of emissions from deforestation and forest degradation. So that was cool. So I think that's going to be a big part that USGS plays, is in terms of helping with biosequestration and looking at making sure that forests are healthy through that Landsat view. I think another big part that we will play is in trying to predict how climate change is going to affect the answer in terms of how ecosystems are going to respond in the future, and how that will change the carbon storage in the biological systems, because there are many things that will happen. It's going to affect soil carbon storage, it's going to affect forest carbon storage, and it's going to be very dependent on the ecological framework that you're in. And I think the USGS is going to have a major role to play in those predictions. Yeah. Well, there is authorizing language in the Secure Water Act that would help us get a more robust network. The issue, of course, is that through a partnership between the states and the USGS, the network was put into place, and over the years, the USGS budget has just been eaten away through inflation with no increases at the USGS. In fact, budget cutting, and the states are in no better shape. So from both sides, we've had to cut back on that network. The Secure Water Act has authorizing language to try to help with that, and we just need the appropriations to try to help, and we know we have many friends in Congress who would like to see that happen. So that'd be great. Yeah, Jim.
Hi, Marcia. A lot of the things you showed us were snapshots, and problems we're dealing with increasingly are going to be global in scope. You're going to need more than a snapshot, more than just one-shot efforts for a short period or a small area. You need a global data set for answering problems like biosequestration. How do you see that developing in the next few years, that effort?
Oh, well, Landsat is a global data set. I mean, I could have shown you the whole planet of Landsat, but that was in my caveats. I wasn't going to do that.
How do you integrate that in the models?
Oh, it has been. It has been. In fact, USGS was mandated by Congress to do an assessment for the U.S. of how much carbon we have stored in our land and soil, or in our soil and our biomass. And that was just published. The rapid assessment just came out and was announced at Copenhagen last week. Secretary of the Interior announced that. And it was done for the lower 48. I think Alaska is going to be added to it soon. And that was just the first sort of rapid assessment, the first blush. But that methodology could be used elsewhere, but for the soil carbon, that required data from the U.S. Department of Agriculture. So depending on whether other countries track soil carbon the same way USDA does, then they could come up with similar assessments. Yes, Steve.
Marcia, I'd like to ask a question relevant to your expertise in marine geology and physics. What do you see the USGS role in the oceans, in particular the US EEZ?
Yeah, the question was, what do you see the USGS role in the EEZ? Okay, well, we've got several important roles there. One is right now we're doing work on law of the sea type work, determining where we might have claims beyond the nominal 200-mile limit because of various geologic or other claims that we might have. And so that's an important role to have. Other work that we have is the same kind of arguments that we can make on the land side for anything to do with climate change, sea level rise, ecology, et cetera, any way that we might be impacted in the coastal zone. So all of that crosses the shoreline, and I think that USGS has a lot of expertise in that area. I think that the USGS has an important role to play in the bottom of the ocean in the EEZ. The amount of territory under U.S. jurisdiction in the EEZ doubles the amount of territory that the U.S. has that's subaerial. And while we have other agencies such as NOAA that have a lot of expertise in the water column, the USGS is the agency that has a lot of expertise that's on and below the sea floor. And as we start moving into the continental shelf and the continental slope for things like wind farms and other structures that require stable bottoms, I think it's important that we have geologists involved in the assessments of what kind of substrates are we actually installing these structures on, how permanent is that bottom, and will these structures be safe, and will they withstand the test of time? Okay. Thanks.
It's a little hazardous up here. There's no rail. So next time you're giving a review talk and you have that stack of somewhere between 5 and 30 papers there and you're wondering whether you'll be able to do them justice, remember that Marcia gave herself less than a month to try to summarize the work of an almost 9,000 person organization. And so I'd like to thank her for giving us some wonderful snapshots of some of the many things, areas of science that people in the USGS are working on. Thank you, Mark.